Hi everyone, this is Puriya Tavakkoli, instructor of Robo 240. The fourth experiment of Robo 240 is deflections of beams. The objective is to experimentally determine the deflections of a simply supported beam and to compare it with theoretical values. On the second page of the lab sheet, you can find some important information about the beam. The length of the beam, in other words, the distance between support A and support B, is equal to 600 millimeter. On the lab sheet, it's denoted by capital L. The cross section of the beam is rectangular, and the area moment of inertia for a rectangle about its neutral axis is calculated by BH in power of 3 over 12. B refers to base of the rectangle and H refers to height of the rectangle. B and H can be found on second page of the lab sheet. They are shown by capital B and capital H. As I said, beam is made of steel. Its Young modulus, denoted by capital E, is provided on the second page as well. It's equal to 210 gigapascal. Also on second page, you can find a table need to be filled. It provides us with point of interest at which we will measure the deflection of the beam. The first one is x equal to 50 millimeter. In other words, we will measure the deflection of the beam at a point located 50 millimeter from the left support. I have already mounted the deflection indicator at the first point, x equal to 50 millimeter. I have already mounted the deflection indicator at x equal to 50 millimeter, the distance between the left support and the point of interest, x equal to 50 millimeter. Also, I have mounted the hanger on which we will put the load of 40 Newton. The distance between the hanger and left support is equal to 450 millimeter, shown by lowercase a on page 2 of the lab sheet. And the distance between the hanger and right support is equal to 150 millimeter, shown by lowercase b on the second page of the lab sheet. The deflection indicator is already zeroed. Now I'm going to apply the load of 40 Newton on the hanger. The location of the load will be fixed during the experiment, but we will measure the deflection of the beam at different locations, at different x provided on the second page of the lab sheet. So as you see on the deflection indicator, the deflection for x equal to 50 millimeter is equal to minus 0.36 millimeter. Now you need to record this number on the second page of the lab sheet under the column of experimental y, but you need to record the number with a positive value. In other words, the first reading is 0.36 millimeter. I will continue the experiment. I will continue measuring the deflection at different x, and at the end I will provide you with the experimental deflections. To complete part A of the experiment, you need to determine the theoretical deflections as well. To do so, go to page 4 of the lab sheet, where you can find this figure and these formula. This figure schematically shows the structure of our beam. Lowercase a, it's equal to 450 millimeter, the distance between left support and the load, and lowercase b refers to the distance between the load and the right support. B in this case it's equal to 150 millimeter. We will use these three equations to calculate the theoretical deflection. Y refers to theoretical deflection. If x is equal to 450 millimeter, you need to use this equation to find theoretical deflection. If x is smaller than 450 millimeter, in other words, if the point of interest is between the left support and the load point, we need to use this equation to find the theoretical deflection. If the point of interest is between the right support and the load point, in other words, if x is greater than 450 millimeter, you need to use this equation to find theoretical deflection. As you see, x is replaced by v, and v is equal to L minus x. L is equal to 600 millimeter, which refers to the distance between the right support and left support. To complete part B of the experiment, you need to draw two curves, one for experimental values and one for theoretical values. In other words, after you finish part A, after you determine the theoretical deflections and measure experimental deflections, you need to transfer that data to this graph to plot two curves, one theoretical deflection versus x, and the other experimental deflection versus x. Thank you for watching. Please let me know if you have any questions.